Okay, so this is a made-up problem. I threw random numbers in for the g of x function here. I also kind of changed the names, you know, how they do with movies. Right? When it's a movie of a real story. Some of the names have been changed to protect, I forget what they say. Anyway, so you are expected to find the coefficient of the x squared term for the h of x function, knowing that it's a Maclaurin series, knowing that g of x has been given to you and it is a Maclaurin series. I have random numbers just thrown on there just to have numbers. So how do we do this? Let's start with what is the Maclaurin formula in general. It is sigma from n equals 0 to infinity of, and what's the formula? If I'm using h of x is equal to nth derivative, if it's Maclaurin at 0, over n factorial, if it's Maclaurin just x to the n. Now, if you need to find the coefficient, why can't I write? Whatever. Coefficient of x squared for h of x's Maclaurin series. That means when n is 2, what is this? So the ultimate find, you want to find the second derivative of h at 0 divided by 2 factorial. This will be your final answer. So what I'm going to do is highlight what I need to find. Now this is my new goal. How do I find h double prime of 0? And I go back and look at it, and I've got, well, h of x is given to me in terms of another function, so how about I start deriving? Yay. First derivative. I have a g of x function as an exponent, baby function, chain rule. Derivative of e to the blah is e to the blah. Give mommy her baby, multiply by derivative of baby. That's first derivative. I need second derivative. Oh, goody! We get to do a product rule and a chain rule's in it. Oh, I was so hoping. Weren't you? That was sarcastic. I guess it wasn't funny. Anyway, so two functions. First function, second function. I'm going to keep multiply by the derivative of the other, and I'm going to come back and focus on it, plus, and then I'm going to switch it up. I'm going to take a derivative and keep the e to the g of x. So the derivative of g prime will be g double prime. Then this one is, I need to take the derivative of this function, but I just did. This is the derivative of that function. Or I could go through the process again of thinking through it, of the derivative of e to the blah is e to the blah times the derivative of that baby function. E to the x is special in derivative world because it comes out as itself, and that causes the product rule as well as the quotient rule to have that as a common term or a common factor of the terms that can be pulled out. So I'm going to take e to the power of g of x, and then I have term 1 and term 2. If I take that out of term 1, if I divide it out, Then I have a g prime of x times another g prime of x, or g prime of x squared. Then my plus sign, and then I have g double prime of x. Now I've got a second derivative of h with respect to x. My goal was the second derivative of h at 0. So now let's plug 0 in. Yeah, this was a 2-minute multiple choice problem. There was something similar to this that was on multiple choice in the no calculator section. Those are the pace of those problems, 2 minutes per problem. Granted, some are going to be faster than others. I believe this was similar to number 30. Tell me if I'm correct, people in class. Yeah. Yes.
Oh, I was just wondering, if there's a problem like this, do you think we should spend our time doing it? Or do you think we should just
Funny.
invest our time in other
First period asked the same exact question. This is not a problem you want to invest time in. But I want you to see how it's done, because I think it's really, really helpful. But this problem isn't worth its time unless you have time to spare. And that's something that's very important as you do the multiple choice. You have to decide what's worth the time, and you do need to skip some problems that are going to be too time consuming. When you decide to skip a problem, make sure you put an answer in. And you will have scratch paper to write on, and that's where you're going to want to write your notes and leave stuff to remember what problems you can go back to. But on the Scantron, make sure you fill an answer in, because you probably won't have time to get back to it. And was that?
So it's about the online AP testing, but at least what I know for the AP psychology test, on the multiple choice questions, you can't go back a question.
Yeah, that's on all of them.
That's on all of them?
All the online ones you can't go back?
Yeah, so once you submit a question, you can't return to it.
That's why we've not been encouraging the online version. Did you decide for online version?
No.
Oh yeah, I wouldn't want it. I'll tell you that. I would not want the online version.
Yeah.
I can't tell you what to do. I don't know what the strategy is for that. But I'm sure there are problems that you're better off making a good guess and moving on. I don't know enough about how they manage those. Anyway, at this point, you're plugging in 0. And to save time, I'm just going to put zeros in here. So now what you need is you have to figure out what is g of 0, g prime of 0, and g double prime of 0. And that's where we finally come back over to this polynomial. And we again remember what is the formula. Ooh, I still need to remember to finish attendance of in-person. Make sure that I get your attendance in before you leave. So if I'm looking at g of x is equal to nth derivative at g at 0 if it's Maclaurin over n factorial x to the n. When n is equal to 0, I get my constant term. But when n is equal to 0, this whole formula just becomes g of 0 itself. So it really helps if you remember that the first term is literally the function's value at the center. When you plug in 1 into your n's, you get the first derivative of g at 0 divided by 1 factorial times x to the 1 power. But then, and notice I'm circling the plus or minus sign with it, this is the second derivative of g at the center divided by 2 factorial. So I need to take this as an equation and solve. So I'm taking positive 2 and I'm multiplying 2 factorial over to it, so I'm getting 4. Now I have my 3 numbers. And I'm going to plug those numbers in. To here. And then I'm good to go. Oh, but no, actually, no, I'm not good to go yet. That's right. There's more. So hold on. That was 5, negative 3, 4. So 5, negative 3, and 4. So 9 plus 4 is 13. This is the answer to h double prime of 0, but the coefficient is h double prime of 0 divided by 2 factorial. So what was that again? 13 e to the 5th power divided by 2 factorial. That is the coefficient. And that was going about it relatively quickly. So anyway, I think that's a really good problem to see how to do. All right, now, after looking at the multiple choice, I decided this needed to be looked at. Okay, if this is f double prime, tell me, where does f have a point of inflection?
At negative 3, because it's an odd power.
Mm-hmm. This is really important. Make sure you're listening. For a point of inflection, yes, you're getting second derivative equal to 0. And maybe undefined. But you have to make sure there's a sign change. Because of this squared, you don't get a sign change at x equals 1. X equals 1 is not a point of inflection. With the odd exponent, you will get a sign change at x equals negative 3. If you are doing free response, they will ask you how you know that's a point of inflection. You need to say because f double prime changes sign at x equals negative 3. That's what they are looking for. You don't even have to be specific about what sign it's changing. And let's see, in this case, it would be changing from negative to positive. The other thing you are allowed to say, and it just depends on the circumstance of what you're given. It wouldn't be this problem, but I will tell you what is equivalent to saying this. Equivalent to that is f prime changes from decreasing to increasing or vice versa. One way or another. You are allowed to use that reasoning as well. Now, I'm debating, should I spend time on this one? Let me warn you about it, and I will come back to it if I have time. This is a type of problem where, do you kind of see that this is a series? But this is a problem that could show up on an A/B test. They have the good fortune of when a series shows up, it is a very specific problem. However, when it shows up, it's a problem that can be difficult to solve. Sometimes it's easy to solve. Sometimes it takes a lot to solve it. You know what? Since I'm here, I might as well go through it. So what I'm going to do is refer you over to, hopefully I still have it up, come on. Right here, page 9 on the outline that I gave you. The definition of the definite integral. These problems, if they show up, are one multiple choice problem, and I want to tell you that that 1 point isn't worth a ton of study time. If you can do it quickly, great. If not, leave it alone. So let me explain briefly. If you cut the x-axis up between two numbers into equal pieces, it doesn't have to be cut up into equal pieces, but that's not what this problem is going to do, because they're going to give you a problem where the delta x is one number, and that's your width. And it's always going to be the length of the interval, which is b minus a, divided into n equal pieces. Now, if that width is the same width for every single rectangle, then the multiplication of that delta x can be directly to the functions inside sigma, or it could even be multiplied outside of sigma. The variable of sigma follows which particular rectangle am I working with. Am I working with rectangle number 1, number 2, number 3, number 4, so on? That variable is often I, but sometimes they use k. The n variable is how many pieces it's cut up into, and that's the variable of the limit, and it is a separate variable. When I run into these problems, I will first look for my width, my delta x. To get through these problems, you need to be familiar with the formulas, that delta x is b minus a over n, and then the heights are the function values with this x sub I plugged in. That formula is based on if I start at a, and if I'm using right endpoints, then my first right endpoint is a plus the width. My second endpoint is a plus twice the width, then a plus 3 times the width, a plus I times the width. These are the two main formulas to focus on. So this formula is going to show up as some number divided by n. That's always my first focus. Do I have a factor? And it's a number divided by n. Do you see a factor? Now, I don't see an n, but the way this particular one is written, they aren't giving you any of the variables. You're having to figure out what they chose for their variables. But I do know, based on what's here, that for sure my delta x is 1 over 50. That I have no doubt of when I look at this. Now, they've got to stick to some reasonable look of the formula, or no one's going to get this. So when I think about the formula being b minus a over n, I'm thinking that most likely they chose n to be 50. And if n is how many rectangles there are, oh, yeah, because that's how many heights I need to add up. I need to add 50 heights up if n is equal to 50. So we've got a match. The other thing that you know is b minus a is equal to 1. I have seen some problems where this fact alone answered who your multiple choice was. This fact alone eliminates one of these 5. However, looking at my choices, I know that my A has to be 0 and my B has to be 1. No doubt on that. And that is another helpful thing. Because my x sub I formula, who is going to go into my function to create the height. So I've got width of rectangle, and I've got height. But my focus is the formula for what I plug into the x, or for what x is to plug into the function. And that formula is a plus I times delta x. Well, I already know delta x. It's 1 over 50. And I figured out that a has to be 0 based on the choices. And what you want to understand about the I, or sometimes they use the letter k, is that it needs to go from 1 to the next integer, to the next integer, to the next integer, to n. However, occasionally it could go starting at 0 to 1 to 2, and in this case end at 49. So it's either 1 to 50 or 0 to 49, depending on if you're dealing with a right or a left endpoint, just so you're aware of that issue. So now that I know that, I'm looking at, this is my formula for the x. So what I could do is I go through and I circle my x's. If I starts at 1, then my first x is 1 over 50. My second x is 2 over 50, 3 over 50, until I reach 50 over 50. Then what I circle, I replace with a big giant X, because it shows itself better that way. Do you see what the function is? It's the square root of x. And so that's technically f of x sub I, but when I make my integral is going from 0 to 1, f of x, and then just a little old dx, because this formula you're going to see in the sigma format, but you only get to see dx when it's in integration short script writing. And that makes B the correct answer. So this is a really old multiple choice problem, and there are others, but I thought I'd show you one and then just move on with it. That's how to focus and deal with those. Yeah.
So the 150 comes because there are 50 slices in the Riemann cell, correct?
What?
The 1 over 50 comes because there are 50 slices in the Riemann cell, right?
The 50 comes from being 50 slices.
Yeah.
That 1 turns into being the difference between the A and the B.
So then what would we do if it was like the limit at n approaches infinity instead of just having the 50
Yeah.
slices?
So the other way it could have shown up was limit as n approaches infinity, and then you would have seen maybe 1 over n, and then square root of, and then let me think for a second, because that then is what this becomes. So what you're actually looking at is the square root of 1 over n, 2 over n, until you reach the square root of n over n. That's what that would look like differently if it had used the n instead of making n 50. So it's not something to spend too much time studying unless you are bored and have studied everything else. So moving on. Another thing that I ran into that didn't go well for people was a problem similar to this. So I changed a few things, and let's do it. They want you to find what y is equal to. You are told that the derivative, we've got a dy dx formula. You need to find y is equal to the f of x function. And hey, look, they gave us a point. Notice that your dy dx, this formula is in terms of y alone. Doesn't have x in it. If I were just doing a straight up integral, that dy dx would be equal to just x stuff. But because it's got some y in it, I'm going to have to do separation of variables to solve. So this problem is wanting us to go through solving. So I want you to take a moment to think about what your first step is. Everyone think about their first step before I write down a correct first step, because I think that may have been where a lot of people went wrong. You need to divide by the entire 5 minus y. And this is a very, very common type of problem. After you do that, then you're on your way to integrate both sides. Do a quick u sub in your head, but do think about the u sub on that left side. If u is equal to 5 minus y, the derivative of 5 minus y with respect to y is negative 1. You get an extra negative 1. Then integrating 1 over u, natural log of the absolute value of u. On the other side, integral of 1 dx is x plus some unknown constant. You're going to figure out that unknown constant through the known point, but when this is the particular type of function where it's a constant over a linear, when you integrate, you get the natural log. Under those circumstances, you're usually better off waiting to solve for the unknown constant. First, isolate natural log. And you can change the minus c into just a plus other letter, but I'm just going to go with it from there. Now, e to the power both sides. And you probably know where this right side is going. This is going to turn into e to the negative x times e to the negative c. When I'm multiplying with the same base, I add the exponents. The plus or minus that the absolute value brings can be absorbed along with that e to the negative c. Like we just get massive absorption of one constant. Call it any letter you like that is not currently being used. And once you do that, that is a good time to find your unknown constant. So I'm going to go back and find it. F of 0 is equal to 3. So 5 minus 3 is 2. E to the 0 is 1. A is 2. The multiple choice problem that I based this off had a little bit more algebra, but not enough to worry about. Isolate the y, So I'm basically kind of changing sides and going y equals 5 minus 2e to the negative x. So be ready to go with that type of a problem. But I warn you, I triple dog warn you. That was supposed to be funny. But what's the integral of this? And some of you thought natural log. Okay, listen very carefully. I've seen this. A calculus teacher had put that of their top 10 mistakes calculus students make on the AP test, this was among the top 10. And I agree. If it is 1 over a linear function, you integrate and you get natural log. And then, maybe an extra times a constant due to the u substitution. But if you've got an exponent on that thing, you are integrating with a completely different formula. You are using the power rule. With the power rule, you're going to want to first rewrite it and then go add 1 to the exponent plus 1. I can do this. There we go. And then divide. Completely different. Don't universalize the issue of, I integrate and it's a logarithm just because it has something on the bottom. If it's a linear polynomial on the bottom, yes. Otherwise, no. Be careful. Okay. Oh, here's one. Okay. I'm going to grab this and move it to where I don't have so much stuff. Get ready. This is not the exact problem you had in a free response problem, but it is similar. And it was mixed with another function that you could integrate. Now, let me tell you that after the AP test, we are going to go through more advanced integration techniques. You will learn how to solve this integral. However, after you learn how to solve this integral, some types, you have no other choice. This type, you do, and you want the better choice. Also, if you are planning to continue your calculus journey and you're going on to calculus 3, you need to get to know this function real well. You want to start recognizing it, and let's start it now. What I'm going to do is I'm going to write y equals and put that down. And let's figure this out. Reverse engineer the equation. Let's see. I can square both sides. Play just a touch more. And I'll know when you've seen it. I will hear it. Well, at least the people in the class. Do you see it? Yep. Do you see it online, people? Oh, wait, I can't even see your anything. No. Oh, okay, you haven't spoken. Suppose it's because I've been ignoring you online. I'm so sorry. Add x squared over, and then all of a sudden, oh, I remember you. You're a circle. This, however, is not a circle. But we're going to see that. First, if you were to graph this, hi, I'm a circle with radius 5. Now, let's go up here. If I took a square root of both sides, I would put a plus or minus. That's what I want you to see. That started as just a plus. So what am I actually working with? I'm working with where y is the positive half. I've got a semicircle. But that's still not enough. Be careful. Go back to the integral. Take a moment to go, hey, what x's are we looking at? So we want to find the area that the integral would cope with from x equals 0 to x equals 5. Find that area, and you have solved the integral. That is a lot faster than the integration technique that can be used to solve that integral. So 1/4 pi r squared and you had a similar problem where you were supposed to integrate that, but what they wanted you to do was draw the graph of that function and integrate the drawing of the graph. So you're going to have to keep in mind throughout your entire AP exam that just because it asks you to solve an integral doesn't mean you're going to solve it in a most expected way manner. There are other ways to solve integrals, and that is to draw the function of the integrand and find area. Okay, then back over to next item on the agenda. I left this as some general questions. I'm going to try and get rid of some of this other stuff to the side. So you have a piecewise defined function, and I'm just saying that this h of x is the function. However, if I'm going from a to b, non-inclusive with b, I'm dealing with f of x. If I'm dealing with between b and c, inclusive of both, g of x is my function. So how do I find the average value of h of x? And how do I find the average rate of change of h of x? And what helps a lot is to actually think, what's the formula? In fact, a lot of these problems work well if you first think, what's the formula? And then look for the pieces of the formula in however they presented the problem. So, average value of h of x, that means I need to integrate my h function from x equals a to x equals c and divide by c minus a. That is what I'm looking for. But then I look at my presentation and I realize that I need to keep that 1 over c minus a and then focus on how do I find the integral from a to c. I will integrate f over particular integral, and then I will add that to integrate g over its particular integral. So from a to b, I follow f, and then I follow g from b to c. And this is as far as I'm going with this generic version. From there, you may have to actually go through integration processes or look for area under curves, something of that nature. Now let me skip over to what if they ask you average rate of change of h. When the word average shows up, it's one of two things which can be put together, but average value of a known function, integrate, divide by interval length. average rate of change of a function is slope formula. So that means h of c minus h of a over c minus a. Then go back and just, you need to find h of c. How do you find h of c? You look at the fact that c is in the domain where it follows g, plug in c. When I want to plug a into my h function, I plug it into the f function. And then c and a are specific numbers. So one of the free response problems you needed to be aware of that with. Now, part B, I'm going back up over to B. How do you express continuity with a piecewise defined function? If the two functions are continuous within their particular intervals, you're not going to worry about proving it. You're just going to be aware of it. Where could this have a discontinuity? At B. So that's what you need to focus on. If you need to show that this function is continuous over the interval from A to C, closed interval, I want to point out that I do have an equal to sign at the A, I have an equal to sign at the C, endpoints are included. With B, the equal to lies with the G function. But you need to know that definition of continuity at a particular point. You need to express the limit as x approaches B from the left, the limit as x approaches B from the right, and one other thing that a lot of people forget to bother with. What's the one other thing that needs to be said? H of B. To be continuous, all three of those need to be found and said to be equal. For the left side of B, you're dealing with x being smaller than B. So you need to rewrite this as the limit for f of x, which would end up being whatever f of b is equal to. Then, as when x is a little bit bigger than b, then g of x is the function that we are focused on, and we plug it in and get g of b. For h of b, look at where the equal to sign is for x equals b. And provided that all three of these are the same number, then you can say that this is continuous at x equals b. And further, that it's continuous over this closed interval. Make sure you know your three value theorems. Be familiar with the hypotheses and the conclusion. You are starting to see that they will ask those in all sorts of forward and backward ways. And I would just recommend keep reading over them and remembering what they are. Now, with any remaining time we have in class, because I knew that I could only get so much done in one class period, I thought I'd throw in a piecewise free response problem. Yes, question.
This is obvious, but I just want to make sure.
Uh-huh.
So if you're trying to integrate a function and it's not continuous, the answer will always be the interval cannot be found or something.
Actually, hold on that thought. In order to solve a definite integral, I'm going to start off with this statement. Actually, f of x must be piecewise continuous from a to b. What does that mean? I'm going to show you with a picture. 10 minutes left. So say from x equals a to some number in between, it's following a function, and then it jumps and is continuous there. You are allowed to solve that integral. Draw straight vertical lines from the function to the x-axis, and that will show you what area goes with it. So you can integrate with a discontinuity as long as it is a discontinuity because the left and right limits aren't equal. Those integrals you can solve. Mm-hmm.
So vertically, because that we cannot solve, right?
If it's a vertical asymptote, then you get to, as a BC test taker, write down that you're solving a limit and see if that limit is solvable or not.
Okay.
And with a vertical asymptote, it depends. Some of them do work, some of them don't. And let me actually refer you again to Desmos. I think I had done this with you guys before, but I don't recall off the top of my head. One over x, as x heads to infinity, that's that harmonic series that we know diverges. 1 over x has perfect symmetry within quadrant 1. So if you have to go looking at between 0 and 1, 1 over x would still be limit does not exist. However, these two swap who works and who doesn't, depending on whether you're looking at the x-axis or the y-axis asymptote. 1 over x squared is drawn to the x-axis very quickly once you are bigger than 1. And if you think about the size of the numbers, it makes sense. What happens when you square that denominator? We have learned through improper integrals with integrating that function from 1 to infinity that this does have a limit to its area. Its exact match, as I look at 0 to 1, is 1 over root x. 1 over root x is the same graph as 1 over x squared, except flipped over y equals x. If you are looking at an integral from 0 to 1 with 1 over root x, that will converge. But if you look at 1 over root x from 1 to infinity, that will diverge. And they flip-flop who converges and who diverges over that 1 over x harmonic. And it's really helpful to be aware of this, especially when a bunch of peas are thrown at you. Not funny. But soon I'm going to go over some of those free response problems with you and talk you through the issues on them. I want to mention something, and I'm going to say it again, very important. When you're dealing with series, you need to write things properly. I spent too long trying to decide yesterday whether to just completely annihilate a bunch of correct work where people failed to write sigma, or to let it go, and sternly warn. If you need to express, if you're testing a series, you need to write the sigma in front of it. You need to tell it, this is the series I am testing. Just the formula alone, you're leaving it up to the grader's discretion. And the AP people will get together and they will decide what is a minimum requirement to receive a point versus what is just not good enough. If you gave them what is definitely good enough, you're not under that scrutiny. So when you have a particular series and you're going to test it, you need to say clearly what your series is. And let me say this. If you are testing for absolute convergence, you need to state, the series I am testing is this series, and rewrite it. Write what it is after the absolute value has been taken. Test that series. Be clear about who you're testing. Then if you get converge from this, that means absolutely converge. And you're done. You don't need to explain any further. But if that's a diverge, then you still need to test the formula as is. State, this is sigma, formula behind it, this is who I'm testing, run the tests on it. And then make a conclusion from there. Make sure you name the tests. And yeah, so we're going to talk about that in more detail soon. Now, going back over to so I recommend that you take a look at the 2010 problem number 1, your allowed a graphing calculator. This is, and just to let you know, this is the last year where they had the first 3 problems with a calculator. After 2010, only the first 2 problems were allowed a calculator. Because the calculators do too much of what you're showing your understanding of. But I would recommend trying this problem out if you want to see if you're getting a little bit better feel for piecewise functions. Then, is there anything that you've run into that you have a question about? You know, I'm going to stop the video.